Okay, one last thing. There is a connection between confidence interval and hypothesis testing. Okay, all right. So first, let's go ahead and just do a quick review or just construct a 95% confidence interval given the sample statistic, shall we? All right, so I have all the information here. Go a little quicker. 95%, that means alpha equals 0.05. So my z critical value, it is 1.96. I looked that up earlier already. Okay, first thing you want to do, calculate your standard error. Okay, and feel free to pause the video and give this a try yourself and check your answer when you're done. Okay, 2.535. All right. Okay, so again, calculate my margin of error. 0.96 times the standard error. Okay, put that in the calculator. Get 0.969. Okay, and then my interval is going to be x bar minus the margin of error, comma x bar plus the margin of error. I have my x bar here, so that will give me interval of this. Okay, now what is the statement that we can make once we have that is, well, we say, well, this is, so we say, so this is a 95% confidence interval for mu, right? For the population mu. We can also make another statement, make a different type of statement that means the same thing. We can say we are 95% confident that the true, right? That the true mu, oh, sorry, I don't really want to say that. Sorry. We are 95% confident that this interval contains the true mu, or the true average, or the true population average, right? Okay, so that's what a confidence interval means. It is an interval estimation for the population parameter. Okay, now how can we use that to calculate, to do this hypothesis test, for example? Well, so take a look here, right? So this null hypothesis, all right, is saying that this is making a statement. This is a statement on the true mu, right? This is saying the true average is 15. Well, we can ask the question, looking at our interval, right? Looking at our interval, so we can say is 15 within this interval. Let me write the interval down here again. The interval that we just calculated, right? 27.969, right? So answer is no, right? Answer is no, right? So we are then, whatever the true hypothesis, whatever the true mu is, right? Whatever the true mu is, right? We don't know exactly what it is. However, we are 95% confident that it's between here. But since 15 is not here, then we can reject the null hypothesis. So no. So therefore, we can use the interval to reject, right? To reject the null. Right? Because we are 95% confident that mu does not, or we can say this way, we are 95% confident that mu does not equal 15. Right? Okay. All right. Now, what about this one? Can I use the interval to test this hypothesis? Oh yes, right. So this is again, this is a two-tailed test, right? And so is 27 within the interval, right? Yes. Right? If the 27 within the interval, now we still don't know if mu is actually 27. However, because 27 is within the interval, it is possible it is possible that mu is indeed 27. So yes, so then if it's yes, then we fail to reject the null hypothesis. Okay, all right. Now, interval, confidence interval, then, right, we can use it to test hypothesis, but not all hypotheses, right? So, long story short, if this is the one-tailed test, then we cannot. So, confidence interval can only test a two-tail. Right? Two-tail hypothesis. If we there is a way, we are not going to cover it, or we don't cover it at this level of statistics class. Right? So if you wanted to test a one-tail hypothesis, then you will have to go through a hypothesis test. So you wouldn't be able to do that with the interval or confidence interval. Okay, so that is all, and just a note, at the end of the handout 9.2, this is a copy from the textbook. Gives you a very nice summary of different hypothesis tests and different scenarios. Okay, so all of the formula is in this part, right, which is on the last page of your handout. All right.